Okay, the class has decided quicksort. So on the class code, qsort. All right, what do we got here? We should copy something over from beforehand so I don't have to, oh, let's take insertion sort. We'll take insertion sort here. Actually, let's just take everything from that lab and dump it right here, and then we'll move insertion sort over to quicksort. Quiz sort? Ooh, that's going to be an interesting one. Quicksort? Quiz. I typed in quiz sort.
No, thank you.
All right, we'll gvim quicksort.
We're not doing quizzes.
Quizzes. Select the font. Put up to 12. Hit OK. All right. So that was insertion sort. What does this make file do? Oh, it does all that. All right.
It does all that.
It does all that.
Okay.
Okay. All right, I think we need to edit this make file real quick.
Sure.
Oh yeah, we have all this timing information, so let's comment that out. And then let's copy over our quicksort from a, well, we have to rename it. Qsort, numbers, all right, call it day, delete everything here. Good, we're done. I just got rid of insertion sort. So quicksort, numbers, and the size, and then we just want to print them out. I equals 0, I is less than size, I plus plus, and let's go ahead and make size something a little more reasonable, like 8. G++, let's see, quicksort, and go ahead and run it. Let's see if we get any seg faults or
You didn't
anything.
do anything inside that folder.
That's perfectly fine. Oh, you're right, I didn't. Why did I do that? Okay. So we'll do scan std cout. Wow, I'm in replace mode. There we go. Numbers sub I to print them all out. We'll go and put a comma just for funsies. And then std cout \n. Oop. For funsies. Alright, so there's some numbers. Those are definitely numbers. Let's make them smaller. Oh wait, hold on. That's not where I want it to be. Where's the rand part? There you are. There, now they're smaller. Great. Okay, so we want to quicksort this. All right, so we get a bunch of numbers. What was the first thing we did with quicksort? We pick the pivot. And really that's just mid. So mid equals, well right now it's len divided by 2. So then int pivot equals numbers sub mid. Then what do we do? We swapped it. All right.
Now we can put on stuff.
So pick the pivot, swap with the beginning. So we'll get int temp equals, we'll do number sub 0. We'll do numbers sub 0 equals pivot. Well, I already saved it pivot as a temp, so I don't need to do this again. So we're going to do this differently. Numbers sub mid equals numbers sub 0, and then of course numbers sub 0 equals pivot. Alright, because I already saved pivot up here.
Yes, you did.
Alright, now what do we do?
Just check to see if stuff after it is less than it.
Right, so we need that small index and large index and larger index. Alright. So int small index, I'll have it equal to, what do I have it equal to? 1? No, 0. Because it has to be the same, that number. And then int index equals 1. Although in actuality it's for int I, which is the index, equals 1. I is less than len, I plus plus. So I is going to represent that index, because you remember from the algorithm, the index was always incrementing by 1, is what was happening otherwise. Okay. So, and what are we checking for? We're checking if numbers sub I is less than the pivot. Is that when we need to do something? Yes. All right. So if it's less than the pivot, what do we do?
Take small index and then you swap
So small let me get caps lock off. Index, increment small index. And then we swap where small index is with number sub I. So int temp equals number sub I. Number sub I equals number sub small index. And then number sub small index equals temp.
Would you want to, if you do it that way, would you want to increment the small index after?
So remember, our small index is starting at 0, so you don't want to swap it with the pivot. You want to swap it with the actual element. That's why we want to increment small index first. Great question. All right. Right here, we're basically creating the what was it? Lower sublist and upper sublist. Huh? The upper sublist. Okay. Well, that was fun. Now what do we do? Remember, the pivot's still at the beginning, so we need to
Switch it with
the small index.
yes.
Right. All right, so swap pivot with small index. So we'll do int temp equals number sub small index, numbers small index, yep, one moment, equals the pivot. Although I'm already saving the pivot, so I don't need to do that. Because I can just do number sub 0 equals number sub small index, and then I can just do number sub small index equals pivot. All right, and that should complete one iteration, right? Hopefully. Let's see what happens. You know, I don't even know what our index was, so we probably should print that out. Let's go ahead and do that here. See out index equals, well, I should say pivot equals. Pivot equals. All right, let's see what we got. So pivot is 86856. Hey, it looks like it actually did that. All right. Huh. We should probably test this a couple more times just to make sure it's working properly. We'll go and give it a different random number seed. This time it's 870. Well, okay, that worked. How about this one? 431. Starting to get some confidence. 182. Oh, looking good. 991. Yep. Notice I'm changing the seed to random, so it gives me different random numbers. Okay, it's looking pretty good. I'm starting to get some good confidence. I'm going to keep testing though, just to show you how important this is. Have I gotten one where it's at the beginning? I don't think so yet. 868, looking good. 79, there we go, it's at the beginning. All right, so we've had a lot that are in between. We've had it where it's at the two extremes. So I'm getting fairly confident about this.
It works.
We'll go back to 100, just to give it, because that's our base. Okay, so that does one iteration, but what is it we need to do once that's done?
Sort again.
Sort again, so we need to call quick sort again. All right, I just realized this is where pointers become magical. So numbers. And constant len. So we need to quick sort. So we need to Q sort the lower sublist and then Q sort the upper sublist. All right, so we need to Q sort. If it's a lower sublist, where does it begin?
0.
Right. So we just pass in numbers. And what's it going to be the length?
Small index.
Yeah, small index. Okay. Let's see if what that does. I'm kind of curious what that does. Whoops, not quite. Small index. Now, small index is actually pointing to what? At that point. It's pointing to the pivot. So we don't want
Index -1.
minus 1. You got it. All right, let's see what that does. Still causing sadness.
Well, have we set a base case yet?
Thank you. We have not set a base case. What would be the base case here?
It's sorted.
If it's sorted or
The length is 0.
length is less than or equal to, well, 0 would be sorted. What else would be sorted? 1.
But,
Okay.
that makes some sense.
All right. So if that's the lower list, how would we Q sort the upper list? Where would it start? This is where power of pointers. Come on, guys. We got this.
Small.
Where does it start? What do I need to type in here?
Small index plus 1.
Okay. Small index plus 1. Okay.
Wait, wouldn't it just
Wait, no, because they moved the
small
pivot
index?
back to the middle, so it should be pivot plus 1, right?
No, wouldn't it just be small index?
All right, well, hold on a second. What's being passed to Q sort? A pointer to
And
array of numbers.
Yeah.
Small index is an integer. It's not a pointer to an integer. So we need to pass a pointer.
make it pointer.
Well, hold on. We can't just magically make it a pointer.
Why not?
I mean, we could. I mean, you're right. We can magically make it a pointer. Would that be correct?
No.
Not at all. So what do we pass to Q sort for the lower sublist? The first one was numbers, because that's pointing to the beginning of the whole list, which is where your lower sublist begins. So now we need to tell it where the upper sublist begins. Where does the upper sublist begin?
Numbers at
Numbers?
small
All right.
index.
Hold on. Numbers? Okay, that's good. And you said at small index?
Yeah.
Now, what's that returning?
That's returning the mid, isn't it?
Yeah, the mid. So we don't want the mid.
You want plus 1?
Okay, plus 1. You're on the right track. We're almost there. Now, what numbers sub small index plus 1? What is that? Is that a pointer or an integer? It's an integer. And what do we want?
Pointer.
Pointer. So what do we actually want here? I gotta wait for y'all to figure this out because this is really, really important. We want it to be a pointer. So what do we do?
Pointer to
How do we make it a pointer?
Start in parentheses.
asterisk.
No, the amper.
Ampersand. Okay, so what's an ampersand? Where would we put the ampersand?
So if you want to tie the pointer to whatever it is you're trying to, the thing getting tied to has the ampersand.
At the where's the ampersand going to go?
Numbers?
Numbers.
Where in numbers?
Right there.
Right,
Left.
right there. No.
Hey, that's good.
At the beginning of it.
Beginning. All right. Someone tell me what that just does. What that just does. What that did.
Passes the reference.
Memory address of it.
Memory address pointing to number sub small index plus 1.
Yes.
All right. Let me tell you another way to do this. because this is probably more intuitive, and that's great. Another way to do this is like that. You take numbers, you add small index, which advances the pointer small index number of times, and then you advance the pointer one more time.
So what about
Oh,
at
yeah.
small index?
What do you mean?
Since we're doing -1 and +1.
Right, we're adding small index.
No, I'm talking about for the, like just passing it.
Let me draw a picture of this. I think that's going to help. You think a picture would help?
Sure.
Maybe.
A little bit.
I need to come up with a. I think for this class, I really need to make pointers like that last lab, and then advanced pointers part 2 and part 3, just to keep y'all practicing dealing with pointers, because I think that's where a lot of the confusion is coming in.
Maybe you should just create like a pointer class.
A pointer? No, that would just make life miserable.
Just a little bit.
Just a little bit. All right.
Make a class about pointers.
All right. So I'll go 5, 4, 2, 1, 6, 9, 8,
25.
7, 25. All right. 6 is the pivot. Everyone okay? We've already chosen 6 to be the pivot. The snail index.
I mean, it can go like a snail.
A small index. What would the small index be?
Oh,
0, 1, 2, 3,
Oh.
4. Right? Because it points to the end of the small index. All right. So what list do we want to sort when we pass to the upper?
the right side.
The 9. Numbers points to this guy. Right? He's a pointer.
Yep.
So numbers plus small index. I decided to use a capital index for some reason. Small index. Where would that point to?
The 9.
So it's 4. 1, 2, 3, 4. So it would actually point to the 6. So we don't want that. We want to go over one more, right? Plus 1. And it points to that 9. Okay? Now, numbers. So, small index plus 1 equals 9. Right? Small index plus 1 is that 9. Therefore, if you take the ampersand of it, it's going to create a pointer that points to the 9. Okay? So these are two different ways to do the same thing, but you're creating a pointer that goes to the beginning of the upper list. All right? Is anyone confused? Very, very important. Okay. Because we're just going to get more and more complicated with pointers as this class continues. All right, so we're pointing to the upper list. What's going to be the length of the upper list?
Half the size of the whole thing.
Not necessarily. So the size is len, because that was passed in up here. Len. So it's going to be len, but it's not the whole thing. You would think half the size, but what if the pivot wasn't in the middle? Well, it was a little on the left, a little on the right. So it can't be just half the size. What number is it based off of? What's this one? 0, 1, 2, 6, 7, 8, 2, 7. Okay. Yes?
Oh.
No, just stretching?
Yeah.
What would be the length of the upper list?
Minus small index.
minus small index. Right. Let's go take a look at that. This camera just does not want to stay straight.
Yeah, I was wondering about that. Why does it keep changing?
I don't know. It doesn't like me. So we're pointing to this 9. We have 1, 2, 3, 4. What's the length of this? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 4 is 5, so we're close. It's small index minus 1. Those off by 1 errors are going to get you every time. Okay. Let's just see what that does. That looks promising. Is that sorted?
No.
Oh no, it's not. We missed one.
33 and 1, 2, 7.
Oh wow. Uh-oh. Wonder what we did wrong. We did something wrong.
Something with the lower one.
Maybe. So in times like this, to help you all with debugging, we already have a print number function. Wow, we should just be using that. Let's print the numbers after the pivot. So print numbers sub len. Oh, I made it all one giant long line? No, we don't want that. Backslash n space. There we go. Yeah, that's much better. So pivot 865, that looks correct. Pivot 479, that looks correct. Pivot 301, that's correct. Pivot 884, that's correct. Looks like what happened is it never recursed up here to include these two numbers. So if the pivot was 301 and then
Just like cut off the other one.
Yeah, I just cut off and ignored the other ones without actually going into them. That's interesting. Huh. So it did not include the whole half because it pivot for 497. It should have done this whole thing. It should have done the entire list, but it ignored the 270 for some reason. Huh. Okay.
It just doesn't like that.
It doesn't like that. Well, let's go down here and look real quick. I think this is where the off by 1 errors really get you. So the lower list, we're going up to, this is where, the off by 1s are getting it. Because notice you're going up to len, you're not including len. So it's not small list minus 1, it's actually just going to be small list. So you capture that last one.
The thing I was saying
There you
all
go.
along.
I'm sure you were saying that all along, but you need to speak up louder and tell me I'm wrong. God, tell me I'm wrong, okay?
I'm a loud person. Stop being
All right, everyone saw how I debugged that? Got to go through these processes of how to debug and figure out what's going on. So those numbers look correct?
She's a bunch of C. Question?
Yes.
Do you think a lot of people overthink when it comes to debugging?
With debugging, I think the main problem people have is they don't use the tools presented to them. They don't spend the time to analyze the issue, like print out, see outs, find out what the actual issue is. Because once I saw something was being chopped off, that implied that our recursion was eliminating the range. So that's how I need to go and look there. What people do is they'll sit down and think about their function too long and not actually evaluate what the results are and try and diagnose the results and go back to it. That's the problem in general. Now, the C-outs are a very classic way to do it. The nice thing about printing something out is almost every program out there will allow you to do this. For some advanced programs, which we haven't really gotten to yet, we're not going to get to in this course, you're really going to need to pull up a full debugger to bring out, and you can actually start investigating different variable names, and that'll help you out as well. So there's different tools at hand, but to answer your question, the main problem is people don't analyze the output. They just try and take guesses as opposed to diagnosing the problem. Was that an answer? All right, so I think I put the seed up to 101, so let's give it a couple more tries just to make sure it's working properly. Yeah, that looks good. Give it 102. Looking good. 103. Looking good. 104. All right, you know what? Let's go ahead and bump this up. Yeah, now it's really tested. Whoa!
That looks good.
Actually, looks pretty good. Let's get rid of this percent over here because it's yeah, not doing exactly what we wanted to. All right. Oh, this is why we did the printout on each line, so it'd be obvious at the end what was happening. Oh, I have a printout down here that's printing them in with commas. So let's get rid of this. Print numbers. Size. Whoa, okay. I'm getting pretty confident about this function. I think it might actually be working. That looks pretty good. I think we just knocked out quicksort. And then I even have, just show you all the pivots if you really want to see them. Okay. Well, that's cool.
Hey.
Hey! Hey! Alright. Hey! Let's get rid of some of these printouts because we want to start doing timing next. Alright, good. Let's also put in optimizations. So there we go. Alright. Now that we have, let's go ahead and just copy and paste that last timing code. Notice I don't even try and remember how it's done. I just copy and paste because that's how you should do it. And we'll do Q-sort on numbers on N. Let's see what that does. Do we, did I not do something here? Q-sort. Clock. Oh, I didn't save. Save. Or maybe I did do it. We do want to reset the numbers. Am I exiting at some point? I'm trying to figure out what happened here. Why is it not running the code? And I'll do the awesome here command. Alright, so compile. So we're here, and it should jump into this. Oh, because size needs to be a bigger number. That's why, because the for loop was never executing. I was trying to figure out why the for loop never executed.
Oh, because it's giving.
Wow, this thing is,
Never mind.
you think this is faster or slower than the other one?
Yeah, so
Sure.
I think so.
Well, let's go take a look at the other one. I think this one's creaming it right now. What are the numbers on the other one? Let's see. Head, insertion sort. What were also the... Oh, that was the CPP. What do I have? Oh, I didn't put the out file. Alright, let's go to insertion sort. G++-O2 insertion sort and a.out. Alright, so that's it spitting out numbers. We'll put it to insertion.out. And we'll send it to the background. Go, go, go. Alright. So it's running in the background. I should probably cat it so we can see that it's happening. Alright, so that's running. Let's go over to Q-sort. Let's do something similar. Get that out. Oops. We didn't want to do insertion sort. We want to do Q-sort. Q-sort. Am I in the right place? Quick sort. Alright, so it's going. We'll put that into Q-sort.out. Oh wait, let me send that to the background. Alright, so they're both in the background. Now let's go look up GNU, our little plot that we made. I know we made a plot. Sort.plot out using with insertion sort. So we're going to go to blah, 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 insertion sort / insertion dot out with tile insertion sort. And then here we're going to, what do we call it? qsort dot out. All right. We'll go with qsort with line. We'll call this one qsort. All right, I wonder if I typed that all correctly. Nope, just got insertion sort, so it couldn't find file qsort. So let's it's because I spelled it wrong. So sort.plot, and it's actually qsort.out. Let's go ahead and do a make. Whoa! Y'all see the difference?
Yes.
Who's winning?
Qsort.
By how much?
A lot.
A lot.
Yikes.
So which one would you prefer?
Qsort. Just a little bit.
N squared to n log n is actually a significant jump. It may not seem like it, but it's a huge, huge jump in performance.
I think you can see that now.
You can see that now. Hopefully that is
Well, we
blank.
saw it first time when you ran it. It was like drastically noticeable.
Yeah, you can just notice it while it's happening, and just so we can at least get a picture of what it. I hope that's how you do comments in GNU plot. What qsort looks like. Let's see if we can just plot qsort.
Nope. Oh.
Oh, it almost looks. It almost looks O of n.
Oh gosh.
It really does.
It's so spiky.
It is spiky. So what this is actually, when you get a lot of spikes, what that's telling you is probably your data set's too small.
Just a little bit.
And let me see if those things have stopped. No, they're still running. Or no, they haven't. They're done. Yep, they're both done. So let's not qsort.out. Let's go look at oh wait, let's go over here. Let's bump this. Let's start adding some zeros.
Oh no.
Let's see how long this takes. Whoops, that's not what I wanted. Let's see how long this takes. Oh, now it's gonna take a. Oh, here we go. Wow.
Oh boy.
Let's increment this as well. Here we go. Compile and run. Okay. I'm still thinking that's a little too much. There's still some jitter in there. There we go. That looks promising. Send that to the background. Let's go ahead and make. Whoops. Where's the plot? Sort.plot. qsort.out. Did I mistype something? Oh, I did. So let's kill that background. Process. Send to the background. And FG brings it to the foreground. So,
Okay, good, because that was my next question.
oh, okay. So I'm going to rerun this program, send it to the background, RM that old out file, remake it. Alright, so now it's,
That's not spunky.
there it goes. Okay, it's starting to get bigger.
Why does it have a little gap in there?
Yeah, we still have some jitter going on. Oh, I know why we have jitter. Because I keep running events. So we're just going to
Oh.
let it run. Let's just let it go. Do 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 do.
Not what I thought you were going to start saying.
What'd you think I was gonna say?
Let it go.
Let it. Oh, that's. Oh yeah. Let it go. My daughter would not stop saying that when I came out. Oh my goodness.
Oh, I love that movie. I saw it twice in theaters.
You did?
Twice.
I did enjoy the movie, except for the ending was very non-Disney-ish because.
It was a lot different than it was going to be.
I feel like people were about to get murdered in that movie or something. Like,
It
that's where
really
went down.
diverged from the original series.
Oh well, yeah. Yeah.
Elsa was supposed to be evil.
Yeah,
Yeah,
she was
Elsa's
supposed to be evil.
supposed to
She's supposed to be blue with light hair, I think. Or blue hair. She's supposed to have blue hair.
Oh, what I didn't like is at the end. What was it? The one per.
I like the one guy got punched. I got died.
What I didn't like is, like one person just did everything. Usually, it's in Disney movies you need everyone to get it done.
It's like teamwork.
It's teamwork. This one was very one person. Yeah, it was.
Girl power.
Yeah, okay, there's that too, but
Yeah,
it's really. It was really like it was only 2 people as opposed to a group of people getting it done, right?
Yeah.
I just
Snowman
like that
helps.
Hans was punched.
Yeah.
I
Hans
mean-
was punched.
I mean,
do
if
like
you look, I literally just watched Tangled last night. If you look at Tangled, it's like one person technically gets it done too. Like he cuts her hair off to save her from her evil mother.
What's up with Lizard?
Yeah, I guess you get a point there.
No.
Although she
Oh,
helps.
okay.
No, I was talking about Flynn Rider when he was
I
like
know.
dying. He cuts her hair to save her instead of saving
The
himself.
lizard is in that movie.
I know.
It's a chameleon. Hold
Whatever.
up, chameleon. It changes colors.
It's adorable.
Hey now. All right.
It's tough, though.
So Q-sort. Wow, Q-sort really does look elevated, but trust me, it is in login if you actually
Well,
bring
because
it.
if you look at the numbers, it's only up to 1.8.
Seconds, yes.
That's pretty
compared to
fast.
all
Yeah,
the-
yeah, it is pretty fast. I wonder how that's how its name came about.
No way.
Nah, no.
No. That's just
No, they
ridiculous.
Just wanted to go fast, and then it hit quick, so it was going to go faster.
All right, any questions about what I just went over here?
Magic?
Magic? Because I will push the code up.
Yay.
So that looks like I've done 1/3 of the project for you. Maybe.
Lab.
Lab, that's right. 1/3 of the lab for you. Maybe not.
I'm sure you did.
I'm never going to guarantee the code we write in class is correct.
Then we're learning incorrect?
Not necessarily.
Just
Setting this up.
add couple stuff to it.
I
I
could-
would never trust class code.
What's that?
Looks pretty good. Trust class code, yeah.
That's good. And you should apply that to every piece of code you meet, including code you wrote last week.
Don't trust it.
That's always been the worst. Reading my code from a week ago. Oh man. I don't know what I was doing. All right.
Yeah, we don't know either.
We don't know either. What's going on? Okay.
That's why comments are important.
Comments are important. Yes. I tried to comment. Doesn't always
Especially
happen.
if you were trying to read stuff from last semester.
Yeah, about that.
To do.
To do. All right. Any other questions? Comments? Screams of angst? Hopefully this you can see how it's not that hard to get the performance numbers out of once you get it kicked off and going. And yeah,
Stuff isn't hard.
that'll be it for today.